When we are given a sequence like 1, 2, 3, 4, 5, it's very easy to find the nth term of that sequence, because the 20th term of the sequence will be 20 and the 40th term will be 40 and 43rd term will be 43 and so on. But what if the sequence is something like 4, 7, 10, 13? How will you find the 25th term of that sequence? Well, if you find that difficult, we are just going to learn that in this video, and let's jump into the video right now. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative which helps you to add an exponent to your learning curve. If you are new to this channel or if you are a first time visitor, I highly recommend that you should click on the subscribe button below and subscribe to the channel right now so that you don't miss out on any future content from us. In this video we are going to talk about arithmetic progressions. There are different kinds of progressions or sequences like linear sequences, which we also called arithmetic sequences, the geometric sequences, there are quadratic sequences and so on. But in this video we are going to concentrate only on arithmetic sequences and how to find the nth term of that sequence for any given sequence, and we are going to address some tricky problems also in the end, so please stick around to the end of the video to learn all the tricks of the trade. So let me start with this very simple sequence. Let's say the sequence that we have is 1, 4, 7, 10, 13 and so on. Now you can look at the sequence and see what the pattern is, and looking at that pattern, if I tell you to find the next 3 terms of the sequence, I think that won't be a problem for you. Will it be? Because we can see that to get any term, if we add 3 to the previous term, we get the next term. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, and seeing that sequence, the next term should be 16. Add 3 to that, you get 19. Add 3 to get that, you get 22, and the sequence will progress indefinitely. Now what if you are told to find what is the 25th term of the sequence? Well, 25th, we will either have to go up to 25, which is not a big deal. You can go up to the 25th term like that. But what if you are told what is the 700th term of the sequence? Now obviously you can't keep writing that down for 700 terms and find what the answer to that is. We obviously need a simple method for that, and to do that, let's first try and understand what's happening in this sequence. So like I said, the first term that we have, so we have got different terms. Let's write them down as in chronological order and what's happening to them. So first, second, third, fourth, fifth. So the first term that I have got is 1. The second term, I'm adding 3 to that. 1 plus 3, that gives me 4. In the third term, I've got 4, which I've already written as 1 plus 3, and I'm adding another 3 to that. So that gives me 7. Then to get the fourth term, I am taking the third term, which is 1 plus 3 plus 3, and I am adding another 3 to that to get 10. And to get the fifth term, I am taking the fourth term, which is 1 plus 3 plus 3 plus 3, and I am adding another 3 to that, and I get 13. So that's how the sequence is progressing. Now let's see. This is the first term that I've got 1. The second term is 1 plus 3. The third term is 1 plus 2 times 3. The fourth term is 1 plus 3 times 3. The fifth term is 1 plus 4 times 3. Now we can see some pattern emerging out of that, the third term, when we have got the third term, we have got 2 times 3. When we are looking at the fourth term, we have got 3 times 3. when we are looking at the fifth term, we've got 4 times 3. So looking at this, what will be the 25th term of the sequence? Well, now it's simple, because now it says we have to take 1 plus 1 less than what the term number is. So I'll take this as 24 times 3. So that gives me 1 plus 72, and the answer I should get, or the 25th term in the sequence, should be 73. Now this is what we did for this sequence. Why not convert it into a proper as a general rule? So to find the general rule, why am I adding 3 here? Do you know why am I adding 3 to each place? Because in the sequence we found that we are adding 3 to each number. So let us call that as the common difference. So let's find that common difference and let's call it D. Now D, you can find it by subtracting the first term from the second term, or the second term from the third term, and so on. Whichever two consecutive terms you take, even if you take 16 and 19, I just take 19 minus 16. So it has to be one term and the term before that. So you'll get it wrong if you do 16 minus 19. It has to be one term and subtract from that the term before it. So 19 minus 16, and that's 3. So let's call this common difference as D. Now looking at this sequence again, the one that we have done, instead of 3, what I'm going to do is, and let me call the first term of the sequence, which is 1 in this case, as A. So let me replace all the 1's by A. I don't need this, so I'll erase this as well, and I replace this by A, this by A, this by A, this by A, and let me replace all the 3's by D. So I've got A in the beginning, the first term, then I've got A plus D, and then A plus 2D, A plus 3D, and A plus 4D. So what do you think the value of the nth term would be? Well, obviously it's simple. It's A plus whatever n is, we subtract 1 out of that, n minus 1 times D. So that's the general rule for finding the nth term of a sequence. Isn't that simple? Well, it's simple to derive it. Let's try and do some questions out of it. I've got this sequence here, and the first thing that we need to know is whether this is an arithmetic sequence or not. So to find that out, what the one property of arithmetic sequence is that there is a common difference D in between each of the terms. So like I told you in the last example, what we need to do is we need to take any term and subtract the previous term out of it. So let's take the first two terms. So I take minus 5 and subtract the term before that, which is negative 2. So since negative and negative becomes positive, so I get negative 5 plus 2. That should give me negative 3. That's the common difference. Or let's take these two terms and see what we get there. Negative 11 minus negative 8. So that becomes negative 11 plus 8, which again gives me negative 3. So we know that the common difference is negative 3. Let's write that down here, and we also need A, which is the first term. So the first term of the sequence we can see here is negative 2. So A is negative 2, and we need to find out what the nth term of the sequence would be. So nth term, obviously the formula, you know that nth term is equal to A plus n minus 1 times D. So let me simplify that as a we know is -2 and plus n minus 1 times -3. That can be simplified further. I'll apply the distributive property here. So multiply this by this and then by this. So that becomes -2 plus -3n, and -3 multiplied by -1 becomes +3. So when I simplify that, it becomes -3n plus 1. So that should be the nth term of this sequence. So now it's easy to find out what the 10th term of the sequence would be, or let's say what the 6th term or 7th term of the sequence would be. To find the 7th term, what we'll do is we can just substitute into any of these formulas that we have found, either into the general formula or into the simplified formula that we have got for this specific sequences. Now please remember, this nth term that we have found out here is specific to this sequence only, whereas this is the general formula that we have. So I'll substitute into both and show you that it doesn't make any difference what way you do it. So let me substitute in the first one here. Let me call that as number 1 and number 2. So if we substitute it in the first term, we get -2, since that's the first term, a, plus we need to find the 7th term. So 7 minus 1 is 6, and times the common difference is -3. So it becomes -2 plus 6 times -3, which is -2 minus 18 is equal to -20. Now is it really -20? So we've got four terms here. Let's try and find the 5th, 6th and 7th terms. So 11 -11 minus 3 will give us -14. -14 minus 3 is -17, and -17 minus 3 is -20. So that's the first, second, third, fourth, fifth, 6th, 7th, and yes, the 7th term is -20. So that means if we substitute our these values of a and d into this equation, we get it right. What if we substitute them into this equation? So let me try that with a different color. So to find the 7th term, it's -3n plus 1. So which means -3 times n we know is we need to find the 7th term, so it should be 7 plus 1. So -3 times 7 is -21 plus 1, that is -20. And you see how both the answers that we got here are exactly the same? Yes. So as I told you, you have to start with the general formula, derive a formula for this specific sequence, and then try and find the value of that. Now this was just to test that we took the 7th term, where it was easy to find but just by going further into the sequence to see what the 5th, 6th and 7th terms are. But what if we need to find what the 30th term is? What will be the 30th term of this sequence? So okay, let's substitute back into the formula. So -3 times 30 plus 1, that's the formula, which is -90 plus 1, which is -89. So that should be the 30th term in the sequence, and if you have the time or the inclination, you can just go ahead and write the sequence for the next 30 terms, and you'll find that you arrive at -89. So that's how you find the nth term of an arithmetic progression. Okay, we have got another sequence here, and to find out if it's an arithmetic sequence or not, let's subtract any two terms. -1.5 minus -1.1, that becomes -1.5 plus 1.1, that gives me -0.4. Let's try with the second and third term. So it's -1.9 minus -1.5. So that means it's negative 1.9 plus 1.5. That again gives me negative 0.4. And the third and fourth terms, we've got negative 2.3 minus negative 1.9, which is negative 2.3 plus 1.9. That again gives me negative 0.4. And yes, since we have a common difference of negative 0.4 in each case, we can see, or we can say that this is an arithmetic sequence or an arithmetic progression where the common difference is negative 3 and the first term that we have is negative 1.1. Once we have got that information, we can erase these rest of the things that we need to move ahead. We need some space, so we'll just erase this and get along with it. So we need to find what the nth term, what will be the general rule for the nth term of this sequence. So let's try and find out the nth term of any arithmetic sequence. We know nth term is a plus n minus 1 times d. So in this case we have got a is negative 1.1 plus n minus 1, we leave it like that, times, I'm sorry, the difference that we had found out was negative 0.4. You didn't tell me earlier that I wrote negative 3 there. So that's n minus 1 times negative 0.4. So when I simplify that, that becomes negative 1.1 plus, then applying the distributive property, it becomes negative 0.4n, and negative then becomes positive, so plus 0.4. Now negative 1.1 plus 0.4, that can be simplified as negative 0.7, and instead of this being plus, it will become a minus, so it will be minus 0.4n, or I can say that minus 0.4n minus 0.7 is the nth term of this sequence. So let's try and find out what the 10th term of the sequence would be. So 10th term would be negative 0.4 times 10 minus 0.7, which means negative 4 minus 0.7, which is negative 4.7. That is going to be the 10th term. What will be the 25th term of the sequence? So it will be negative 0.4 multiplied by 25 minus 0.7, and negative 0.4 times 25 will give me negative 10 minus 0.7, that gives me negative 10.0, sorry, negative 10.7. That's my 25th term, and so on. Let us see another example. Now here we haven't been given the sequence at all. What we have been given is that the fourth term of the sequence is 3 and the sixth term is 11. We have to find what the nth term of the sequence would be. So to do that, let me write the general rule. We don't know what the general rule or the nth term for this specific sequence would be, but let us write the general formula, which says that the nth term of any sequence is a plus n minus 1 times d. We don't know what the d is here. That we know that the fourth term is 3. So let me write that as a plus 3 is equal to a plus 3d. That is the fourth term, right? And the sixth term would be 11 equals to a plus 5d, right? What we have got is a simultaneous equation with two variables. So it's easy to solve that, isn't it? So let me call this as equation number 1. this as equation number 2. So when I subtract equation number 1 from equation number 2, I get 5d minus 3d becomes 2 times d, a minus a, that gets cancelled out, and 11 minus 3 is equal to 8. That means d is equal to 8 minus 2, 8 divided by 2, which is equal to 4. So we've got d as 4. Now let's try and work out what the value of a is. So to find the value of a, we can substitute it back into any of these equations and see what we get. So let us substitute in equation number 1. So we get 3 is equal to a plus 3 times 4, which means 3 is equal to a plus 12, or a is equal to, so I'll subtract 12 from both sides of the equation. So we get a is equal to 3 minus 12, or equals to negative 9. So we know a is negative 9 and d is 4. So the sequence would be, we'll start from the first term, which is negative 9, add 4 to that, which is the common difference. So negative 9 plus 4 will give me negative 5. Add 4 to that, I get negative 1. Add 4 to that, I get 3. Add 4 to that, I get 7. Add 4 to that, I get 11, and so on. And we can also verify that since if this is the sequence, then what will be the fourth term? So it's 1, 2, 3. Fourth term is 3, which we can see right here is also 3, and sixth term is 11, which we have also been given is 11. So we have to find the nth term of this sequence. So nth term, now it's easy to find out. So nth term would be a plus n minus 1 times d. So that will be the nth term, and since we have the values of both n, a and d now, so it will become negative 9 plus n minus 1 times 4. Since d is equal to 4, I'll simplify that and I get negative 9 plus 4n minus 4, or I can also write it as 4n minus 13. That's the general formula. Now we'll try and find out what the sequence would be if we are given this formula, or the nth term is already given and we have to find some term. So here we have got another example that we are given the nth term of a sequence, which is 7n minus 6. What we need to do is, we are not given the first term, we don't know what the common difference is, we just know the formula for the nth term of this specific sequence. And what we need to do is, we need to find the 10th term, the 50th term, and the 100th term, and then we also have to figure out whether 78 is a part of the sequence or not. So let's try and work that out. So for the 10th term, since the formula is 7n minus 6, so it will be 7 times 10 minus 6, which is 70, minus 6, which is equal to 64. So that's the 10th term. The 50th term would be 7 times 50. 7n minus 6 is there, so 7 times 50 minus 6, which is equal to 350 minus 6, or 344. That's the 50th term. And 100th term would be 7 times 100 minus 6, or it is 700 minus 6, which is equal to 694. That's the 100th term of this sequence. Now we need to find out if 78 is a part of the sequence or not. So let's put that back in the formula of the nth term. So we know that the nth term of this sequence is 7n minus 6. If 78 is a part of this sequence, then it should be there in this sequence. We don't know which term it is, so we'll just write that as 7n minus 6. We add 8 to both sides of the equation, so we are left with 7n is equal to 78 plus 6, or 7n is equal to 84. I divide both sides of the equation by 7. and I can see that 7 goes into 84 12 times. So therefore n is equal to 12. That means if n 70, that means 78 is part of the sequence, and it's the 12th term in the sequence that will be 78. And we can figure that out. We can then we don't need to find the common difference, we don't need to find what the first term is, but we can obviously figure that out by the first term would be 7 times 1 minus 6, so that will be 1. The second term would be 7 times 2 14 minus 6, that will be 8. This third term would be 7 times 3, which is 21 minus 6, that will be 15, and so on. If you come to the 10th term, you will find that it is 64. If you come to the 12th term, you will find that it is 78, and so on. And the last question for today, which is a very simple question, is that if the nth term of a sequence is 3.5n minus 0.5, write the sequence. So let's take the first term. First term would be 3.5 times 1 minus 0.5, which is 3.5 minus 0.5, which is equal to 3. That's the first term. Second term would be 3.5 times 2 minus 0.5, or 7 minus 0.5, which will be 6.5. The third term would be 3.5 times 3 minus 0.5, which is 10.5 minus 0.5 equals to 10. The fourth term would be 3.5 times 4 minus 0.5. 3.5 times 4 is 14 minus 0.5, that is 13.5, and so on. So the sequence would be 3, 6.5, 10, 13.5, and so on. That will be the sequence. So I hope you have learned something useful out of this video, and this was all about the nth term of an arithmetic progression or an arithmetic sequence. And if you liked the video, I would definitely recommend that you share it with your friends also, because you learned something out of it, and it's useful if they also learn something out of the videos. Tell them to subscribe to our channel. And if you haven't subscribed to our channel yourself as yet, please click on the subscribe button here, and do not forget to press on the bell notification, because that will notify each time a new video is uploaded. And you can watch these videos on the left side as the next videos in the series. And take care. God bless.